Hello guys, how are you today? So today I'll be explaining the course practice of chapter 4 AP Chemistry. Anyways, without further ado, let me get started with the first question. In the first question, it says, what is the number of electrons in NO+? So we need to do the Lewis structure of NO+. First of all, we start with NO. N is in which group? It's in group 5 plus O in group 6. And remember, it's plus, so we will need to remove one electron. 5 plus 6 minus 1, that's going to be 10. Now we'll subtract from it 2 electrons because we used a single bond pair, right? So that's going to leave us with 8. That means 8 divided by 2, 4 lone pairs. That means 1, 2, 3, 4. Now, of course, oxygen completes the octet, nitrogen does not, so we will change it into a triple bond. So now both oxygen and nitrogen complete the octet. Now, they told us to determine the number of electrons in NO+. The lone pairs of N, it has only one lone pair. First of all, that means we eliminate B, D, and E as an option. Then, we have oxygen having also one lone pair. So, still so far so good. Now, bonding pairs, we have only 1, 2, 3 bonding pairs. That means the correct answer would be C. Okay, so that's why C is the correct answer. We'll move on to question number 2. What are the most adequate values for angles 1, 2, and 3? Okay, question number 2. Given the structure of ethanoic acid, what are the most adequate values for angles 1, 2, and 3? So, first of all, to find out the value of the angles, we'll need to take the central atoms into consideration. So if we took carbon as our central atom over here, right, it's connected to 1, 2, 3, 4. So this is AX4. AX4 is a tetrahedral. In the tetrahedral, the only angle it has is what is 109.5 degrees. That means directly we say that for the first angle, it's 109.5. So we eliminate all other possibilities. Now, for the second central atom, which is this carbon over here, it's connected to 1, 2, 3. So this is a trigonal planar. And in the trigonal planar, they only have 120 degrees as the angle. So the angle here is 120 degrees. So based on what we have, we will choose the one that says 120 degrees. So definitely A is going to be the correct option. We'll move on to question number 3. What does it say? Which of the following is the weakest type of interaction? For sure, out of all of them, it's the intermolecular force. And in between the intermolecular forces, the London dispersion force, or ID forces, are the weakest forces. We'll move on to question number 4. Why is the boiling point of hexane higher than that of pentane? Now, hexane is what? Hexane is C6H14. Pentane is C5H12. Now, when comparing C6H14 and C5H12, you will notice that C6H14 has more electrons. And we said, the more electrons we have, the larger the electron cloud. The larger the electron cloud, the more polarizable it is. The more polarizable it is, the stronger the ID forces are. The stronger the ID forces are, the more heat we will need to break the bonds. The more heat we need to break the bonds, the more the boiling point will increase. Okay, so this is basically the explanation. Now, why the boiling point of hexane is higher than that of 2-methyl-pentane? Hexane is C6H14. 2-methyl-pentane, let us draw it. It is 1, 2, 3, 4, 5. This is, first of all, pentane. And then 2-methyl, so here we have CH3, and then everything else is what is H. Okay, so everything else around here is the H, and then the C6H14, if we were to draw it, it would be what? It would be like just like this, basically, right? So by looking at this, you will see that definitely for sure, this, I think there's one more carbon I missed. That's fine. definitely for sure this has a longer parent chain, it has a longer skeleton. So due to the longer parent chain, the longer skeleton, it will have a larger surface area, and due to this larger surface area it will have more contact, right? So with the more contact, it will result in stronger London dispersion forces. We'll move on to question number 5. What does it say in question number 5? Consider the structures of ethylamine and ethane. Which row is true about ethane and ethylamine? First of all, which of them is soluble in water? For sure, ethane is what? Is a non-polar molecule because it's a hydrocarbon, only hydrogen and carbon, so it's non-polar. That means it's insoluble in water. Ethylamine has nitrogen, right? And this nitrogen is like the whole structure of this is asymmetrical, which is amazing. We need it to be asymmetrical first of all. So it's asymmetrical. Then, second of all, nitrogen has a lone pair. And third of all, nitrogen is one of the electronegative, right? So with these, it will form what? It will form a hydrogen bond. So which of them is soluble in water? It's definitely ethylamine because it exhibits hydrogen bonding. We'll move on to question number 6. What does it say? Consider the following two structures, ethyl, methyl, ether, propanol. Okay, so they want the molecule with the higher boiling point and why? Very simply, over here, this oxygen is not bonded to a hydrogen. If it's not bonded to a hydrogen, then it cannot form a hydrogen bond. So we forget about something called hydrogen bond. Here, this oxygen is bonded to a hydrogen. So because of this, it will be able to form a hydrogen bond. So which of them has a higher boiling point? Definitely this one. Why? Because the strongest force it has is the hydrogen bond. Here, the strongest force is the dipole-dipole. So the hydrogen bond, okay, will have strong forces. So propanol will definitely have the higher boiling point because it exhibits hydrogen bonding, which is not found in ethyl, methyl, ether. In addition to ID, ID, and PD, or DPDP forces. Okay, so the answer is D. We'll move on to question number 7. Consider the boiling point of hydrides of group V. Which of the following explains the trend of boiling points from pH3 to SbH3? Okay, we will not take into consideration what will not take into consideration NH3. Okay, so they want from pH3 to SbH3. So what is the forces acting pH3, ASH3 and SbH3? So if we draw them, we're gonna get what? We're gonna get pH3. This is what pH3 looks like. So it's definitely what? It's AX3E, which is a non-symmetrical, so it's definitely a polar molecule. Because it is polar, that means it has what? It has the permanent dipole-dipole forces. But these dipole-dipole forces are not going to explain anything. The only thing that explains the boiling point and the melting point differences is the LDF. Okay? So, all of them have LDF, but of course, the differences in the LDF will change the boiling point. So the one with the more electrons, which is SbH3, right, is going to have a greater electron cloud, and this will be more polarizable. So the strength of the London dispersion forces increases, and due to this, there will be an increase in the boiling point. Now, why H2O is an anomaly? It is an anomaly, first of all, because it forms hydrogen bonds. And also the solid is less dense than the liquid, and it has a high surface tension, and it's a universal solvent, and so many different reasons why H2O is an anomaly. Question 7 now, we move on to question 8. What does it say? Why is the boiling point of Cl2 higher than that of F2? Both Cl2 and F2 are what? Are nonpolar, so the only force acting on them is the London dispersion force, right? So London dispersion force, how do we compare? We compare on the number of electrons. For sure, Cl2 has a greater number of electrons. Okay, so what does this mean? This means that the electron cloud of Cl2 is more polarizable than that of F2. This is due to the number of electrons in Cl2 being greater than F2. So now, if the electron cloud is more polarizable, the strength of the London dispersion forces increases, and so then the boiling point increases. So the correct answer is 1 and 2. We'll move on to question number 9. Which of the following are anomalous properties of water? Again, we said that it's less dense in solid state than liquid state. It has high This is wrong. It has a high boiling point and melting point, and it has a high surface tension. It forms hydrogen bonds, and it's a universal solvent. We'll move on to question number 10. Okay, here, basically, I'm not gonna really waste too much time on this because you guys are supposed to know how to do this one by yourself. You're supposed to draw the structures of each of these, right? Now, after you draw the structures, I'm just gonna like explain it really briefly. After you draw the structures of each and every single one of these, you're gonna see, okay, based on my species, if I have AX3, AX5E, AX I don't know what, as long as you have a species and you know what the species is, you will look at it and then you will look at the shape. Shape can be trigonal planar, tetrahedral, trigonal pyramidal, blah blah blah, so on and so forth. And then you will look at what? You will look at the bond angles. Of course, trigonal planar is 120 degrees. Now, when we say that it's less than 109.5 degrees, the only time we will use 107 and 104 is for ammonia and H2O. These are the only exceptions where we should know them, right? So NH3 is 107, H2O is 104. This is the only thing we have to have memorized, okay? And so everything else, you can do it by yourself. I'm gonna skip this question because it's gonna take too much time. I'll go to question number 11. Use the given data to drag and drop the type of bond between the following pairs of atoms. So first of all, you need to find the change in electronegativity, so delta En. MgNF, it is, what's 4 minus 1.2? It is 2.8, so it's greater than 2, so it's ionic. S and F, so 2.5, 4 minus 2.5, that's gonna be 1.5, so it's covalent. F and F is definitely covalent at 0. And then Li and S. Li and S, even if you did subtraction, you're gonna get 1.5. It's not a covalent. Why? Because Li is a metal and S is considered a non-metal. So metal plus non-metal will give me ionic, even if the electronegativity difference is less than 2, then no, still if it's a metal and non-metal, it's gonna be what? It's gonna be an ionic. We move on till 12. We have HF, BeCl2, H2O, BF3, POCl3. Now, we need to know whether they're polar or non-polar. What are the two conditions for them to be polar or non-polar? First of all, you have to see if they are symmetrical, right? Second of all, you have to see if all surrounding atoms are the same. They have to all be the same. All surrounding atoms must be same. And with these conditions, you will achieve non-polarity. HF, for sure, just by looking at it, you will see it's polar. Now, BeCl2, if you drew it, it would be like this. And it's what? It's a linear structure. So what's the species? It's AX2. AX2 is symmetrical, and both surrounding atoms are the same, so for sure it's gonna be non-polar. H2O, it's like this. It's a bent V shape, right? So this is AX2E2, so it's not symmetrical. So directly we say that it is polar. BF3, BF3. It's gonna give us what? It's gonna give us AX3. AX3 is symmetrical and all surrounding atoms are the same, so it's non-polar. POCl3, this is gonna give us AX4, right? When you draw it, it will give you AX4, but the only difference is that you have Cl and P, and Cl and P are two different atoms, so they cannot be non-polar. They have to be what? They have to be polar. We'll move on to question number 13. Consider the three structures that can be drawn for N2O. So you just need to find the formal charges. How do you find the formal charge? You take the central atom. You will take the group of the central, like not the central atom, just like take any random atom and you take the group of this atom. For example, nitrogen is group 5. I will subtract from it what? I will subtract from it the number of surrounding electrons. So 1, 2, 3, 4, 5, and 6. 5 minus 6 minus 1. So this is the formal charge. And then you need to do the same exact process for every single atom and you will get the answer for all of them. Now, which structure that best represents N2O? Now, honestly, you can eliminate structure 3 directly because of the triple bond. Oxygen will never form a triple bond with nitrogen. Like, it may form, by the way, it may form a triple bond, but it's less likely to form a triple bond. Like, oxygen will not form a triple bond. Okay? Now, between structure 1 and structure 2, you need to take the most electronegative atom, which in this case is what is oxygen. So oxygen, you need to make sure that it holds the lowest charge. What's the lowest charge? -1. So if it holds the lowest charge, for example, here the lowest charge is here, we don't want this. Lowest charge is also here, so we don't want this. So this is why we'll eliminate structure 3 and structure 1. So we're going to be left with this, with oxygen, the most electronegative, carrying the negative charge. Okay? This is why structure 2 is the best option. Now, what's the number of sigma and pi bonds for the most stable structure? So we have 1 sigma, 2 sigma, 1 pi, 2 pi. So 2 sigma and 2 pi. We move on to question number 14. Okay, when you see nonpolar directly, it's ID-ID, LDF forces. When you see special type of interaction with hydrogen and very electronegative nitrogen, oxygen, fluorine, hydrogen bonding, directly, you think of that. Now, temporary dipole, you think of induced dipole, instantaneous dipole, so ID-ID. Strongest type of intermolecular forces is the hydrogen bonding, and non-polar molecules is ID-ID. So it's all in the keywords. The enthalpy change of decomposition. Important. Decomposition means we're breaking what? We're breaking intramolecular, not intermolecular. We're breaking intramolecular. Whereas vaporization, we're changing a state, we're breaking intermolecular. So intramolecular will require more energy than intramolecular. To break the intramolecular will require more energy than to break the intermolecular, because it involves breaking the chemical bonds. Move on to question number 16. As we go down the group, the boiling point increases. Why is this? It has to do with the LDF forces, because as we go down the group, there's a greater number of electrons. Greater number of electrons means a bigger cloud. Bigger cloud means it's distorted easy. If it's distorted easy, that means that the ID forces are strong, and when it's strong, that means we'll have a stronger and a higher boiling point. 17. Okay, here directly I see OH. When I see a highly electronegative atom bonded to a hydrogen, I directly think of hydrogen bonding. NaCl, Na plus, Cl minus. Ions, so ionic bonding. Zn is a metal, so definitely it's a metallic bonding. Okay, HBr. This is not ionic. H plus, Br minus, they're both non-metal, so non-metal and non-metal, definitely covalent. But we'll not say anything about covalent forces. Instead, we'll focus on the intermolecular forces. So, it is, first of all, HBr. So, it's not F, it's not oxygen, it's not nitrogen, so it cannot be a hydrogen bond. But, however, it is polar, because there's a difference, right? So, it is polar, so that's why we'll say it's a permanent dipole force. Now, finally, here, it's non-polar, right? So, this is why we say it's an ID force, because it's non-polar and there's no hydrogen bond. Now, last but not least, the interactions between water molecules and ions is called ion dipole interactions. It's very easy, so thank you guys for watching. I hope you enjoyed and have a wonderful day.